Hello everyone, in today's video I'm going to be showing you my toy language named Plexia. Plexia is a toy language I made in a couple hours with no external dependencies, and the entire thing is written in Python. So I'm going to do a quick demo here. I'm going to launch the shell, which is easily launched by typing in python shell.py, and we are now in the Plexia interactive shell. So if I go back to the README here, we can see that we can do calculations, comments, we can create variables, or we can output something to standard output. I have just realized that this is incorrect. Just give me a second to update it. My mouse cursor is bugging out a bit. Yeah, okay, back here. So let's try all these out. So the first one, calc. The calc function essentially calculates something and outputs it. So 1 plus 1 should output 2. Yep. This doesn't respect or support bed mass. So 1 plus 1 times 4, well, this should equal 5, but it's actually going to give us 8. Because it's evaluating this expression first, so 1 plus 1, which is 2, and then multiplying it by 4, so 8. Instead of using bed mass and doing 1 times 4, and then adding it to plus 1, we're supposed to give you 5. Again, something I didn't really implement because this was made in a couple hours, like 1 or 2 hours. Yeah. The next one here, we have comments. Nothing special. This is a comment, and it just gets ignored. Next up, we have creating variables. So you essentially just add the variable name. So I can just say, I don't know, foo equals, and then expression. So no strings. The only data type we have are ints. So I can do 10 divided by 5 plus 2 times 5. Wait. No, we can't do that. Times 9 plus 2. So I can now print it to the standard output by doing print $foo, and that gives us 5.6. I am not going to confirm that this is correct because I cannot. Well, actually, no, I can. 218. Yeah, okay, something's messed up in the calculations. Not fine. But yeah, you can also use this in other. You can also use variables in other variables. So you can say phi equals $foo times 3, and then you can print phi, and you get 15. Wait, 5.6 times. Oh, calc 5.6 times 3. You can't convert to a float. So yeah, this program is still very, very buggy, but I'm proud of it. So now I'm going to show off the code. So let's close down the terminal, and the first file I want to show off is the Lexer slash Tokenizer. So the Lexer or Tokenizer's role in the program is to generate tokens, so we don't have to deal with strings. Like if I check out test.plexia, we don't need to deal with strings, but rather classes. So we have the left bracket. I don't know why this is paren, but okay, sure. Plus, minus, div, new line equals. You can see these all inherit token, which really all they do, they all have this token type, which in all honesty I forgot I even created. Because when I get to the parser here, you'll see I'm using the instance function rather than checking the token type. I'll probably change that at one point. We also have token with the value, which is just what it says on the tin, a token with a value. And then inside the actual Lexer itself, we loop over all the lines provided. Each line is a string, obviously. Or is there a string? Yeah, it's a string. So the keyword is the first element in this list that we split, and we essentially go through each word. See here, words, and we will just append each class based on what the word is to this list called tokenized line. Down here, we essentially try to convert it to an integer. I should probably change this to a float, as you saw, so we'll do float. Can we do try? Okay, I'm gonna try something real quick here. Haha, pun not intended. Try float word tokenized line dot append number. Now I need to import math so I can float it down. So import math. Live coding here. So we're gonna do math dot floor word. I need to convert this to an integer though. Int word, but then also need to convert it back to a string because that's how the program works. So str, and then accept value error pass. So yeah, now we're just trying to convert it to an int. If that doesn't work, we're going to try to convert it to a float. If that doesn't work, we'll just continue. Pass. And then we return the tokens at the end. So the parser is the big one. So at the top of the file, we're importing everything from the Lexer. And then inside of the parser's init function, we just take an Lexer and initialize our variables. The first function we have is evaluate expression. So what this is going to do is that it does what the function name says. It evaluates an expression and returns the expression at the end of the function. So at the top of the file, we just check the length of tokens because this is a list. If it is 1, we just return its value. Next up, I try to get all the operands inside of the token list. So an operand is something like plus, minus, div, or mul. So I store all of those in the OP indexes list, and yeah, I see what I'm talking about. Instead of using token type, all I'm using is instance. So we check if the token is either an instance of plus, minus, mul, or div, and if it is, we append it to OP indexes as I, the index, and then token itself. So now we have the current value, which is set to 0 because, yes, we can't set it to anything other than that, or else it's going to give us an inaccurate answer. We loop over the OP indexes. We store the value of each OP index from behind the operand and after the operand. And then we get the token. And then here, all we're doing is we're checking if it's an instance of each. Again, I'm not using token type. And you'll see here that I'm doing val1 plus val2, but we only do that if I equals 0. So only if this is the beginning of the list, we're going to do val1 plus val2. If not, we're going to do current value plus val2, because val1 has already been added to the answer in the previous iteration of the for loop. Then at the end, we return the value. Next up, we have the get value function. This gets a value, as it says on the in the function name. So it takes a couple tokens, and we see here that there's a couple of comments basically explaining what each code snippet does. So if there's only one variable inside of the tokens list, and then we just return the value of that from self.variables. Next up, we check if it's numbers. And I got this from a Stack Overflow answer. I don't know where it is, but I think a quick Google search should bring you there. This checks if any token is an instance of variable, or if not, rather. So if we don't have any variables in there, just numbers, then we will, yeah, I forgot what this was. In English, try this is just trying to mitigate a bug, but then we'll just return an evaluated expression with tokens. Next up, we have variables and numbers. So here we just have a final token list, and essentially what we're doing is we're checking if it's a variable, and if it's a variable, we are going to convert that variable to a number based on its value, and if it's not a variable, we just append it to the list and then evaluate the expression. And then finally, variables, this is the literal exact same thing, just it's just variables. And then finally, the parse function, which checks each keyword's value and executes a function based on it. So calc prints out an evaluated expression with all the tokens in the line. So token here, we're calling the tokenize function inside of the Lexer. That's specs. And print, we are printing out get value using tokenized line, and then this down here is for creating a variable. So we're checking if the second token is equals, and if it is, I am deleting the first two tokens in that list because those are the keyword and the equal sign, and then we just create a new variable based on keyword.value and everything else in the tokenized list. And that is how Plexia works. Main.py is a simple CLI file which runs Plexia. So it takes in a file argument and just it parses through the entire file using the parser and args a file.read, which reads the file. And then shell.py, as you can see here, is just a regular Python shell. So anyways, thank you for watching. The source code is on GitHub. I will leave a link in the description. Thank you for watching. Happy New Year, and I will see you in the next video.